My name is Russ. Happy Wednesday to you. Every Wednesday at 11:30, we go live here on IndustryCast to talk about the industry that we are involved with, which is manufacturing. To talk about how you can improve as a manufacturing engineer, grow your career. That is our mission. Our mission is to always be adding value to our customers, either through the companies that we represent or by sharing lessons that we have learned along the way. So that's what IndustryCast is all about. Today, we're talking about choosing a chassis system for your automation project, what to consider, the different chassis options that are out there, some pluses and minuses on a couple of those chassis options. And then we're going to have a few myths that we're going to bust at the end. So stick around and stay tuned for what those are going to be. Again, like I mentioned, we go live every Wednesday here on IndustryCast. And we represent these companies. This is the only marketing process that we have, or marketing talk that we have during this. We want to make sure that you understand the companies that we represent. We are in North Carolina, South Carolina, and Virginia, and we work with ATC Automation out of Cookeville, Tennessee. 85% of ATC's business is with repeat customers. That says a lot. Not every project that we have completed has been amazing, but because we follow through, our customers always come back. Cincinnati Test Systems is the largest leak test company in the world. I can't believe I'm saying that. I started working with them back in 1994 as a wet behind the ears manufacturing engineer at Cummins Engine Company. So I've been with them for a long time, and they have grown, expanded, purchased, and just become an amazing organization with every type of leak test that you would ever want, also functional testing. Duquesne Plastic Joining, another fantastic company, a global and diverse plastic joining company, hot plate welding, vibration welding, laser welding, ultrasonic welding, spin welding, you name it, welding, infrared, hot gas, they do it. They weld plastic components better than any company out there. And you talk about following through. I mean, Duquesne is the most customer-focused organization that I have ever experienced in my career. Symetric is a division of Cincinnati Test Systems. They're focused on high-speed in-process data and data management, data collection, data processing. Think Industry 4.0 and all of the data analysis that we're doing nowadays with Industry, so Industry 4.0, but then also the artificial intelligence and making smart decisions with the technologies or with the data. And then Keller Technologies right here in Fort Mill, South Carolina, they're focused on industrial air filtration. They do wet as well as dry air filtration. All right, that's the only commercial. Now let's hop into today's topic. We're going to talk about chassis types. So first, I'm just going to run through the different types of chassis that you might choose or might consider for your automation project. Lean cells, these are more manual, operator loaded, lower cost options. The operator loads the component, hits the opto buttons, and maybe the machine does the process. Maybe they just manually press something in. It just depends on the level of automation and price that the customer wants to spend for the application. Very cycle time oriented. So the beauty of a lean cell, in theory, if you have 5 stations, you can run those 5 stations with one person. If your capacity increases, you can add a second person, then add a third person, then add a fourth person, then add a fifth person. So we're assuming that all those stations are balanced as far as the cycle time, but then you can scale. So it's probably the most scalable of the chassis that are out there. Now, from an overall capacity perspective, you're still going to be limited by the operator content associated with the station. And then we have the Rotary Dial, very common. We have a good friend. His name is Mike Janko. We call him Dr. Dial. He is one of the applications engineers, longtime applications engineers at ATC Automation. But we always joke that he could put anything on a dial. Dials are very efficient. They rotate from station to station, and then there's an operation at each of those stations. Or maybe you have an idle station, but you can do your testing on the station or on the dial. So dials are very floor space friendly. So they are a smaller package with a lot of work done. Think high speed, faster type of application, not high speed, but faster, smaller products that you would assemble utilizing the rotary dial. a palletized system. So these are very common, the Bosch chassis, the logo mats that are out there, any number nowadays. I think they're a lot more palletized, but we are a Bosch Star integrator at ATC Automation. So we use a lot of Bosch products, but the palletized system is the part transfers on a pallet from station to station. The processes, maybe there's some manual. So it's a lean cell. And ideally you think about this, it's a lean cell that has a pallet running through it, is kind of how you might envision that. Precision Link is another type of chassis similar to the Rotary Dial, only it has a more elongated footprint, and again, allows you to do work off of the station. So pretty unique product that we use a lot in the medical applications is where we apply that. I think some of our consumer product, higher volume applications, we use that as well. A walking beam, we use this a lot of times for larger parts where you're processing it through. So the walking beam goes under, up, steps through, steps down, up, 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 up. So that's how the walking beam progresses the part through the stations. The servo-driven chassis. So nowadays, especially with companies like Weiss, I think Allen Bradley has their own servo-driven or magnetic type of chassis. So these move independent. So the stations that we've talked about, the Rotary Dial, the palletized system, well, the palletized is independent, but you're dependent on the next station getting finished before the pallet moves into the next station. The Precision Link is dependent on the previous process. The walking beam cycle time is dependent on the previous process. The servo-driven chassis, in theory, and not, I guess not in theory, but it does allow greater flexibility because the part transfer mechanisms or pallets or whatever we want to call them, pucks, they move independently. So they, one can move forward, and then if this process takes a little longer, then the other will catch up and it can accelerate and decelerate. They're pretty flexible as it relates to the cycle time. So servo-driven chassis and the magnetized type of conveyors. You can investigate those out there. It's very fun to watch if you ever go to like the assembly show and they have these moving around. They're very neat. I think finding the right application, that is the key. That's the key to all these chassis, but those in particular are a challenge. And then we have robot cells, which are obviously robot driven. The robot does most of the processes in the cells, and we don't think of it as a chassis, but it is another form of automation chassis. That's how we're moving the part through. That's how I want you to think of chassis. That's how we move the parts through the process. Okay, so here are the criteria for selecting the chassis for your specific application. Cycle time requirements. If you have a 2-second cycle time, you're not going to want to put it on a lean cell. I can't imagine that you would. Operators just can't move that fast, right? So your cycle time is going to drive the general strategy for your chassis. Now, when I didn't talk about there is continuous motion, and the reason I didn't talk about that is because that's not something that we do in any of our processes. So I'm not super familiar with continuous motion, other than to say it's pretty amazing technology in that it doesn't crash all the time because it's going so dang fast. But so cycle time requirements are going to drive a lot of decisions that we're going to make. So we're going to go to a rotary, depending on the cycle time, Precision Link. Those are going to drive us if we have those lower cycle times. If we want to achieve a lower cycle time or faster cycle time on a palletized system, we have to look at multiples. So we go, 2 up, 4 up, 8 up, 10 up, 12 up. So that's how you can get increased capacity on a pallet type system. But at some point in time, it's less efficient and doesn't make a lot of sense to add that many parts to a pallet system. So cycle time is a major consideration when you're trying to determine which chassis to utilize. Part size is going to dictate a lot of the chassis selection as well. So if you've got a bread box size application, say you've got a throttle body or you've got a manifold, then that's something you could definitely use in a lean cell type of application. If you've got a faster cycle time requirements, then you're going to want to put that on a pallet, depending on the part weight. You're going to put that on the pallet as well. So the part weight, as far as moving it around, is that going to be ergonomically um, okay for the operator? That's going to be something that you're going to need to communicate and ask with your safety folks. But the part size, weight, as well as the size itself are going to have a say or determination. It's going to be something to consider when you're determining which chassis to utilize. Floor space. I mentioned the Rotary Dial is a way to put a lot of automation in a small spot. The challenge with the Rotary Dial is access. And we're going to talk about that here in a minute as it relates to our ability to maintain and the maintenance of the equipment. Floor space is, again, that's critical. So where are you going to put it? Do you have enough room to put a palletized system? How is that going to be configured? Future expansion. So something that you're going to want to think about in choosing a chassis. Some of these chassis are fixed. So if you're going to use a rotary, unless you leave stations open on the rotary, so you select a larger rotary diameter and you leave some of those stations open, you're not going to have any way of adding to your existing capital in order to increase the number of products that you're putting out. So to decrease the cycle time, increase your throughput, that is going to be limited on a dial if you don't build that into the application. So, what do you want to do for future expansion? What's the vision for this equipment? And take that into consideration when you are choosing the chassis type as well. I'll talk more about the future expansion concept in the Mythbusters section that we're going to have here shortly. Part tolerances. How precise, how precision do you need the equipment to be? Some of the technologies will lend themselves to a more precise assembly process than the others will. So that has to be something that you are keeping in mind for the application. And then serviceability, maintainability, those are key components, key considerations as well for the application. Again, that those dials are awesome, but sometimes there's not a lot of room, there's not a lot of space. Now, there's a company called Weiss that has a really awesome ring dial. And I think there are other companies, I think, that probably have the ring dial as well. But the ring dial has an open center, and that open center allows you to put some of the technology inside the machine. So rather than, on a traditional dial, you've got a big table that's turning. And so, of course, you can't put much on the table other than the fixtures that are going to hold the parts themselves. But with the ring dial, you've got a ring. So it's a ring, and then the center is cut out, and the ring moves. And so you're able to put presses, torque guns, different assembly processes inside, and they work to the ring. So that allows you better access, better serviceability, better maintainability. So the ring dial, that's something that we really utilize a lot at ATC. Cost or price, of course, if you have limited budget, you're not going to utilize a Bosch palletized systems. You're probably going to be focused on more lean manual type of operations. So that would be more of a lean cell. So from a pricing perspective, lean cells are typically, not always, but typically the most cost-effective technology that you're going to use from a chassis perspective. The palletized systems get up there in price. The precision links, those are pretty robust and can be, costly systems as well. I think, robot is a very inexpensive system as well. The problem with the robot, or the challenge with the robot, is that you're limited from a speed of the robot perspective for getting additional products out. But from a scalability perspective, you can duplicate those robot cells as well for getting additional capacity. So again, any number of things to consider and think about when choosing these chassis systems. And another thing is your experience, or your company's experience. If your company doesn't have experience with robots, but has experience with dials, that is definitely going to be part of the consideration, because if you bring in something that they've never experienced, the learning curve can be quite painful. I've had a lot of customers experience the learning curve. They didn't have any automation. They brought in automation, and then that became it was a challenge. So it's a challenge for companies that don't have automation when you bring automation in, because you don't have an automation mindset. Flexibility of redeployment. And a lot of companies, they have this idea that we're going to redeploy this equipment for a new product when this product goes away. So that is something that you might want to consider as well. But we're going to address that again in the Mythbusters section. So now we're going to do a little compare and contrast, pluses, minuses for two of these products, the Rotary Dial being the first one that we're going to talk about. So from a pluses perspective, it is a lower cost solution. Now the least cost, I should say the least costly is the lean cell, but as it relates to the more automated part carrying stations or technologies, the Rotary Dial is definitely the most cost effective of those options. It has a smaller footprint, faster cycle times. The product can return to operator. Obviously, you could also unload it using technology as well. It is excellent for those smaller component precision applications as well. So some of the minuses, depending on which type that you purchase, you're going to have limited access. So if you buy a traditional tabletop dial, you're going to have all of your processors are going to be on the outside. So they're going to be outside moving in. And when you have it on the outside moving in, obviously it's difficult to access the fixtures and the tooling that's actually on the dial, and making adjustments can be quite a challenge with that. So limited access could be an issue for your maintenance folks. And you have a lack of flexibility. So if that part changes, a new part type, future changes, there's really limited flexibility for rotary applications. So you're pretty locked into that technology for that specific application. Palletized systems. So Bosch, Logomat, there are any number of suppliers out there. So from a pluses perspective, it is definitely the most flexible of all the technologies. You can retool a pallet. You can adjust each station. You can add products with new tooling. So there's a great deal of flexibility that goes with the palletized system. It's excellent access for maintenance. It's ideal for larger parts. Now, when I say larger parts, I'm talking bread box size, maybe a little bigger than that. But when you get much larger than that, you're probably still going to use a pallet, but not in the same concept of this Bosch or Bosch type of pallet, smaller unit. So some of the minuses have a much larger footprint. So if you can imagine, you've got a loop, a racetrack, and so that center of that racetrack is floor space that you're not going to get back. You're not able to utilize if you make an over and under, that's a more efficient use of that floor space for sure. But the challenge that comes in there is the cost associated with running that pallet back, and there's no real benefit other than obviously floor space to the additional cost that you are going to have to invest in order to achieve that over and under type of format. So it's a much larger footprint than, say, a dial. It is more expensive than the dial systems. It is limited in precision. So we talked about the precision of the dial systems. We're going to have limited precision when processing parts on the pallet. Now, that's not to say that we can't achieve a level of precision. We can use locators. We can do any number of things. But if you can imagine, you've got 20 different pallets. So you've got 20 different fixtures for your part. And depending on how it comes in the station, how the pallets were machined, how precision those pallets were machined, each one is going to be a little bit like a snowflake. So getting the repeatability that we want for those precision applications can be quite a challenge, and you can chase your tail a lot when you are having issues with repeatability for your applications or for your products. Multiple sets of tooling required for pallets. That's if you have multiple parts that you're running on the same line, you're going to have multiple sets of tooling for those. So you got to have a place to store them and everything else. Okay, myths, or I should have said or instead of and, stretched truths as it relates to chassis systems. I have seen this, and we have our customers often request this. Their management tricks themselves into believing this, and it can create some challenges. Okay, the myth of flexibility. So we often hear, we want to plan for the future. We want this equipment to be flexible. And then we say, okay, what is the envelope? What is the potential future product that you're going to run on the line? Well, we don't know. But we want to build in that flexibility for those future applications. Now, I don't mean to be cynical, but there is a cost associated with two things here: building in capacity or building in flexibility for things that we don't know. So there's a cost associated with that. And then the second part is there's uncertainty. And uncertainty probably costs more than the first one. When we are machine builders, we want to know exactly what it is that we are putting together. And when we are throwing apples and oranges and pears at a piece of equipment for ultimate flexibility, we are going to lose some of the efficiency. We're going to lose some of the certainty associated with running one product on the piece of equipment. And my experience has been that the likelihood of a customer adding a new product to an existing line is slim to none. Now, there are certainly exceptions. I've got some wonderful customers that have added multiple times. They've added to palletized systems. We have retooled and we have upfitted their equipment so that they could run 5 different products on the same line. So there is some definite validity to this flexibility concept, but don't trick yourself. You can't design for something that is not designed. That's a myth and something that is a stretched truth. Another one, the myth of redeployment or repurpose. Well, we may want to redeploy or repurpose this equipment someday. That makes a lot of sense, right? Why not utilize your capital, double down, use it again? The challenge comes in is that the equipment, that the product that's getting replaced is going to need to ramp up at the same time that the new product is going to be installed, or I mean, is going to need to be moved out of production. So the timing never overlaps perfectly so that we can redeploy a piece of equipment to manufacture another product. So oftentimes what happens is that equipment gets scrapped versus redeployed or repurposed. But we convince ourselves in the beginning that we're going to build in that redeployability or that flexibility, that future utilization of this equipment, rather than just, again, eliminate the uncertainty and just focus on building the piece of equipment that you need to optimally assemble your products. That's what we all need to be doing and focusing on, rather than this stuff that may or may not happen. So the myth of expansion. So we're going to build in future capacity. I see this a lot, like in a conveyor type system. We had a customer that we would build in 10-foot sections. In those 10-foot sections, it had all the quick connects and everything else. So you could disconnect it and you could set another station in there and you could reconnect it and in theory, just move, right on with it. I can count on one hand how many times that customer, and they purchased probably 6 lines from us, and I can count on one hand how many times they actually utilized the expansion capabilities of that product. So if you're going to build in expansion, the idea of expansion, oftentimes we think about not adding to the existing equipment, but duplicating the existing equipment. So that is often that's an option for you to consider when you're thinking about, right now I need to run 100,000 units a year. So you build a piece of equipment to run that, but I may need to run 200,000 next year. Well, you duplicate the 100,000 piece of equipment that you've got. It's going to be more efficient. It'll be better the second time around because you'll have the experience, you'll have the knowledge, you'll have the know-how to get the equipment up and going more quickly. So those are some myths or stretched truths in our industry: the myth of flexibility, the myth of redeployment, and the myth of future expansion. All right. Can't thank you enough for taking the time. Robert G., I hope you have an amazing rest of the day. We appreciate your business. We do not exist without you, the customer. And if you have any ideas, anything that you would like for us to address or talk about on IndustryCast, please let us know. We will do the research and we will present accordingly. So if you need anything in Western North Carolina or South Carolina, get a hold of Matt Matheny. Wonderful guy, very knowledgeable. super helpful in moving your projects forward. Chris Mullins, we all know Chris. We love Chris. He is an amazing human being, Eastern North Carolina and Virginia. And then yours truly, however I can help, I am ready to support you. Until next time, until next week, please stay cool, stay tuned, and we'll see you soon.